Our sun sits at the center of our solar system and provides light and energy for all the planets within. It is around 5 billion years old, is nearly 1.3 times larger than Earth, and has a diameter of over 864,400 miles. With a mass of over 1.9 octillion kilograms, it makes up over 99% of all of the overall matter in our solar system. So where did our sun come from, and how was it created? Let's explore. Like all stars, our story begins 5 billion years ago in a nebula cloud. A nebula cloud is a collection of loose particles that are free-floating in space. This nebula cloud is made up of dust, hydrogen, helium, and other ionized gases. Elements other than hydrogen often come from stars of previous generations that are now being recycled to create new stars. A nebula cloud may lay dormant for long periods of time, such as millions of years. However, when an outside force, such as a supernova, acts upon this cloud, particles begin to move and stick to one another. Once particles begin to stick to one another within the nebula cloud, gravity begins to pull in more and more material from the nebula cloud into one central location. As the mass increases by accreting more material, the central object begins to spin faster and faster due to an increase in the angular momentum. This is very similar to a figure skater who pulls her arms and legs in to her body to spin faster. This fast spinning in tandem with the increase in mass causes a steady increase in temperature in the central object. Once the central object begins to accrete more and more mass, all of the surrounding material begins to spin around it, creating an accretionary disk. Once enough matter reaches the middle of the accretionary disk, the central object begins to glow, creating a protostar. When the star reaches around 10 million Kelvin, it begins to fuse two hydrogen atoms into a helium atom. This fusion reaction releases energy for the entire solar system to use, including our Earth. Once fusion has started, our star is officially born. It then begins to give massive amounts of energy, and if we could even harness 2% of the sun's energy that hits the planet, it would solve the world's energy crisis. So, 5 billion years later, our sun still provides us with all the energy that we need to sustain life on Earth. Furthermore, our sun will continue to burn for another 5 billion years until it begins its slow death into a white dwarf, destroying the Earth in the process. It will first expand into a very large and red sun until it eventually becomes too massive and collapses on itself, creating a supernova. However, until that day, we can still look forward to seeing the sun in the sky every day.